Hello everybody, so welcome to the first step of our CMake in 3 easy steps tutorial. In this step 1, we will compile Hello Modern CMake World program in several ways, and by the end of this tutorial you will have an understanding of commonly used CMake options. So after this tutorial you will be understanding what the following command does, like CMake-b build, -g ninja, -d CMake compiler clang, and so on. Here basically we are telling CMake that please create a release build inside the build folder by using Ninja as a build automation tool and then the clang as a compiler. And while doing this, please enable all the warnings that I indicated inside the CMake lists file. Wow, lots of things to do. First, I suggest to remind ourselves what this CMake is. When we go to Wikipedia and then look at the definition of CMake, it says that CMake is a cross-platform, free and independent source software for build automation, testing, packing, and then installation. So CMake is going to be creating make files for us if we are choosing Make as a build automation tool. If we are choosing Ninja as a build automation tool, it's going to be creating a Ninja build file for us. If we are using VS Code, then Microsoft Visual Studio, it's going to be creating solution files for us, which is great news, right? It also says that it is compile independent, right? So I'm going to do all the job for you. It is saying that it is cross-platform, which means that if you use Unix in your code development, I will also compile it for you in the Windows environment, say, which is great news. In this step 1 phase of our tutorial series, we should investigate whether CMake is keeping its promises. While doing this, I created a repo for you, which is called a repeat introduction to modern CMake, and then step 1 resides inside the step 1 branch of our repo. So if you want to code with me, so you can simply clone this repo and then follow along with me. Let's see how CMake works. I have a simpler project here, as you can see, and it's simply a main.c resides in the driver folder in our case, and which simply tries to say hello to modern CMake. Just like Make, CMake enters the root of the project and then it looks for a CMake file, which is called CMake lists. Let's have a look at what is inside this CMake lists. First, CMake list starts with a declaration of minimum required version of CMake. In this case, I am telling, hey, in this project, please use the CMake minimum version 3.10. So the minimum version of CMake in my system should be 3.10, so any version greater than 3.10 will work. 3 is important here because modern CMake starts with version 3. So let's have a look at what version do I have inside my system. So when I check, I see that CMake version is 3.19 and I'm good to go. Good. Next, I am setting the C standard of my project as 11. So something that I would be using -std equals C11 if I wanted to compile from the command line. And also if I want to enforce that C11 must be used, then I need to use CMake C standard required option. Otherwise, it could decay to the previous standard. Next, I'm giving a name to my project. In this case, I said non-trivial CMake example. I don't know why I called like this, although it's a trivial example though. Okay, so we can simply add some options over CMake file so that we can control these options from the command line. In this case, I am saying, hey, I want to create an option which is called enable warnings. I am giving a simple description here, saying that compile with all warnings, and I'm setting this on. As we can see later on, we can simply disable this option from the command line. Next, and simple interesting thing here, I'm saying that if the enable warnings is set and it is on, and if the compiler is GNU or Apple, so if you are using the Unix-like environment, please add the compile options -full and -extra. But if we are in the Windows environment and using Microsoft Visual Studio code, so Microsoft Visual Studio compiler, then add the compile options as -W4 because CL inside Windows does not understand -4-extra. So here we need to explicitly indicate the compile options that we want to be used. Next, we are telling CMake to go to the subdirectory driver. Then CMake will keep on its journey from the driver folder. So when it enters the driver folder, it looks for the CMake file, which is called CMake lists again. So we hit and then try to understand what's happening here. First, I give a name to this project. So I want to create an executable, and then I want to make it as project as well, which will make my life easier. I'm calling it as driver. Next, I am telling CMake that I'm going to be creating an executable, and I'm going to giving it a name as main. So the executable will be called as main, and the source file of main is main.c, which resides inside the driver folder. So how to tell this to the CMake? Project source dir macro is in CMake simply refers to the most recent project that has been used. In our case, this project driver. Project driver's folder is driver. Therefore, when this guy is expanded, it's going to be called driver. So CMake will be searching the main.c inside driver main.c, which is something that we want. So basically, after all this step, we are telling CMake to create a main executable by using the standard 11, by using the warning /4-extra, and by using the source file as main.c. In our CMake lists file, we didn't indicate any compiler. And as you shall see in a moment, we will see that CMake is going to be making an intelligent choice, and then it will be choosing CCC for us as a default option. So let's see how this thing works. First thing, CMake is a utility actually. When I call CMake from this folder, then CMake will be producing its output inside this folder, so my project folder, so to say. And I don't want this because I don't want my project folder to be polluted. So I simply create a build directory, which is most of build choice. So the name of a directory that is going to be created most of the time chosen as build. You can call it anything like objects or whatever. In this case, I'm creating a build directory and then I'm checking out to that directory. Now I'm inside the build directory. Now I'm telling CMake that, hey, please act on the parent directory and then produce your output inside this directory. Let's hit and see what happens. CMake detected I have a GCC here, right? And then it created a build folder. Build folder is something that I created. It's created some files inside of it. And then when I see that, it creates some make file for me. So two things to note. It chose GCC as default compiler. But if I click, for example, here in my VS Code, you can see that I have another compiler, Clang, as well. So CMake is making an assumption here. So it has a default choice. Next, it is using make. It is making another assumption that this guy is inside the Unix verb. Probably he will want to use make as a build automation system, and it's creating a make file for us automatically. So what is inside this make? What it's gonna do? I'm just wondering, and then calling make with this -n option to see it, to run it as dry run, to see what's gonna happen if I call CMake. So it is telling me that if you hit make, then I'm going to be going to the driver folder. I'm going to be using this GCC as default compiler. I'm going to be using this options -4-extra. I'm going to using GNU11 and yeah, as a standard, and then I'm going to be using source file main.c, which is something that I really want CMake to do, which is great news. And in fact, if I simply call make, then it's going to be creating the main executable for me. So if I go to this build driver, I realize that main is there. So let's go and try to .-driver main, and I say hello modern CMake. Awesome, thank you CMake. Good. Okay, so let's go back and then remove this folder. Everything is good, my system is all great, everything is working fine, and CMake is working fine. Now I want to tell you about the plugin that VS Code is using, which is very great, nice plugin, which is in my case called CMake. So plugins reside here. If you have this CMake plugin, it is called CMake Tools, which is an excellent plugin, and we shall be using and understanding its usage. So I go and simply want to build my project by the help of this plugin. So let's do it. Ctrl+Shift+P. I'm saying please CMake configure this project. When I hit build, so when I hit configure, I realized that it is using some sort of commands, and it created build for me. So it created build directory right away for me. Right? It created a directory and called it as build, as default. When I click, then I realized that there is no make file here. So what's happening here? It created Ninja. Right? It's created Ninja files for me right away. Ninja build files. Do I have Ninja in my system? Apparently it should be true. Yeah, I have the Ninja in my system. So if I simply go and call build, right, it created this make folder, is make executable inside the driver folder. It is main here, and it is also accessible at this point. And if I run it in terminal, it says hello more than CMake, which is great news. And this plugin has another super advantage that I want to show you. For example, if I go here and then put a breakpoint out there, and then if I go to the main and then I say that if I want to debug, then it simply set all this debugger for me, and everything is working for me. This is great news, because setting a debugger inside Visual Studio Code is not that trivial. So this is great news.